Welcome to this video where I want to dive into some common Angular questions. Now, to be honest, these are just the questions that came into my mind when I thought about which questions I see a lot. If you got other questions, please share them in the comments of the video. I probably won't be able to answer them all there, but I will note them and I might do another video of this kind in the future. And with that, let's just get started and see which questions I got. Let's start with one thing that sometimes leads to a lot of confusion: the Angular version jungle. We got Angular 2, 4, 5, 6, soon at least. So what are all these versions about? Well, let's have a look. In the past, we had Angular 1. It was released in 2010, and it was not the first JavaScript framework manipulating the DOM, but it still started a little bit of a revolution, you could say. It suddenly allowed people to create single-page applications. It made controlling the DOM and dynamically rendering content there so much easier. And it still also had issues. Performance could become an issue in bigger apps, and this was one of the major reasons why the team decided to do a complete rewrite of Angular and release Angular 2 in 2016. Now, the road to Angular 2 was pretty long. A lot of versions were released in between, a lot of beta versions. But in the end, we had a brand new framework that still allows us to create engaging user experiences in the browser, but with a different focus. Angular 2 and all the versions thereafter focus on creating single-page applications, and they are highly component-driven. So like in React and so on, you build components. So the key takeaway here is that Angular 2 has nothing in common with Angular 1. It's a complete rewrite and it inherits some concepts, but the majority of things you use in Angular 2 is brand new or works totally different than it did in Angular 1. Now, what about the other versions? Now, due to that difference in the capabilities, we nowadays typically refer to Angular 1 as AngularJS. That's the name of the framework nowadays. And Angular 2 and all versions thereafter are simply referred to as Angular. Just Angular. Speaking of that, why do we have more versions than just Angular 2? Because the Angular team adopted semantic versioning, which means there are major releases, minor releases, and patch releases. So maybe they're just fixing some bugs, maybe they're introducing some major new features, and the version number indicates that. The important thing is Angular 3 and 4 and so on are not complete rewrites of Angular 2. Speaking of that, we never had an Angular 3 due to internal version differences with the router and so on. So Angular 4 was the next release, and thereafter we had 5, 6, and so on. Now, at the point of time recording this, Angular 6 isn't out yet, but new versions will come out every few months due to that semantic versioning. And you can actually see a schedule of past and future Angular versions on the official Angular GitHub repository. A link to that schedule can be found in the video description. There you see the more recent versions that were released in the past and when we will see Angular 6 and 7 approximately. Now again, if you look at these versions, it looks like everything you'll learn will be, well, stuff you don't need once the new version is out, and that is not the case. The version upgrades are backward compatible, and thus far, until Angular 5, we had no upgrade that introduced any major breaking changes at all. And there is a long-term version support, so a version which will receive security patches and so on, even if it's a bit older. Currently, that's Angular 4. So you can find more information on that page. The key takeaway is Angular 5, 6, 7 and so on is the new normality because it's not a new framework every time, it's just an update, just as we have React 16, 17, 15 and so on. Now that we understood the different versions of Angular, let's have a look at how we create Angular projects. Now, chances are you already know this, and I'm not going to show you the exact steps here. You might know that there is the Angular CLI you can use. The question is, do I need the CLI? Do you need the CLI? I get this question a lot. People especially people coming from jQuery or Angular 1, are used to dropping the Angular import into their HTML files and starting to use Angular. Unfortunately, that does not work with Angular 2+. One of the major reasons is that we use TypeScript instead of vanilla JavaScript. So the language in which we write our code doesn't run natively in the browser. Obviously, we need a compilation step in between, and whilst theoretically you could do that compilation in the browser, it's not really recommended. It's a big performance hit. We also have components and templates that use the Angular template language. This also needs to be compiled by Angular, so from JavaScript to JavaScript, but to a different JavaScript which has a meaning to Angular. And this could also happen in the browser, but again, for performance reasons, it's recommended to do this on the client, so on your development machine actually. And we also probably want to employ some optimizations like minifying our code and so on. This also should be done during development or at the end of it, right before shipping the app to production. So whilst we do have all these options of running the TypeScript compilation in the browser or running the Angular template compilation in the browser, this does not work. So we want to do it in the development setup, in the development workflow, and the same is true for bundling, minifying, implementing lazy loading, and stuff like that. Now, for that, we use tools like Webpack or TypeScript, of course, also minification and optimization tools, and Babel possibly to also transpile some features, though here we use TypeScript, so probably not. There are more tools still included in all of that for all the optimizations and all these steps. And you can set up such a workflow on your own. What you can't do is just drop it into the browser and use it without taking a huge performance hit at least. But the easiest way, really, to get around all of that is to use the CLI. The CLI gives you a really good and flexible workflow. You can eject from a CLI project to get access to the underlying Webpack config, so it's not a login. But starting with it, creating projects with it, and using its capabilities really is a good approach. Because the CLI team, which is part of the Angular team kind of, is actively working on the CLI and keeps on improving it to give you ever better Angular performance, ever better Angular apps generated by the CLI. So I can only encourage you to use it. You might not find another GitHub boilerplate that is that actively developed. Now that we had a look at the CLI, let's say we opened Angular in our editor, and let's say that editor is Visual Studio Code. I often get asked which extensions I can recommend for it. And I might not be the person with the most extensions. I'm a fan of only using a few. And for Angular, there really is one major extension I want to recommend, and that is the Angular Essentials extension from John Papa. This is an extension that bundles a lot of other extensions. So if you go to the extensions part of Visual Studio Code and you open that extension, you see the other extensions it includes. And these extensions really make developing Angular apps much more fun. You get better auto-completion, you get nice syntax highlighting, all that fun stuff with the installation of just that single extension. So definitely have a look at that. Let's leave the setup world and let's have a look at the real development problems we face when creating an Angular app. And debugging Angular apps tends to be one of the hardest things from my experience, so from the questions I saw. And one thing that really isn't done correctly a lot of the time, unfortunately, is reading the error messages. Angular error messages became a lot better. And often, they give a clear hint about what is wrong or at least where you should look for an error. Sometimes the error message gives an incorrect error but still points at the correct file, and you find another syntax error that led to the incorrect error message. So read the error messages and try to incorporate the information you find in there. Let's have a look at a few. Here are two error messages. The first one says uncaught error template parse errors. App product is not a known element. You often get that if you forget to declare your custom components. So if you didn't add them to the declarations array in app module. Make sure that you check if that's the case. If you did add them to declarations, and you use multiple Angular modules, make sure that they interact correctly with each other, that you don't use a component in a module where this hasn't been added to declarations. That's another common error source. So read these errors and then dive into that part or into that file it's pointing to here, in this case to the app product component, which somehow seems to be unknown. Check the selector for typos. Maybe you have the wrong selector set up in the component decorator of the product component. These are the things you should have a look at. Take these messages seriously, and if you can't find a solution, Google them. You find a lot of GitHub issue threads, a lot of Stack Overflow threads for all kinds of common error messages. Besides reading error messages correctly, also use good old console log debugging. It's not the best debugging approach in the world, and it simply means that you put a bunch of console logs into your code and you log different objects, properties, things you want to have a look at to see them in the JavaScript console in the browser and see the values these properties and so on hold at certain points in your app. This is not the best way to thoroughly debug an app, but to get a quick insight into the state of something, into the state of your app at a given point, this is a good solution. A better solution, of course, is to use the source maps the CLI project gives you automatically. Source maps are little files the Chrome or in general the browser developer tools can use to create a bridge from the compiled and optimized JavaScript code running in the browser to your original files, which are of course easier to read for you. So use these source maps in conjunction with the browser dev tools. Let me show you how this works. Here is a broken Angular app and we got an error. Now let's have a look at the source code from within the dev tools. We can simply click on sources here, and there in a CLI project which creates these source maps I was talking about, you should find that Webpack folder. If you access it in the subfolder in there, you should find a folder which in the end replicates your app structure. So where you find a source app folder with your actual TypeScript files. And now in these files, you can even set breakpoints to stop at certain points of time to get an insight at the value of a certain property, for example. So this is really something I can recommend having a look at, because this is a powerful tool that allows you to take an in-depth look at your app and dynamically debug it with breakpoints, with all the features the developer tools gives you in your TypeScript files, even though these are not the files running in the browser. So this is really powerful. Use these tools. And you get that for free. In a CLI project, you can just dive into your source code like this. There also is another tool besides the already implemented browser developer tools the browsers ship with, and that's Augury. That's a Chrome extension which you can install from the Chrome extension store. It's free, of course. And this is a tool that gives you detailed insight into your app at runtime. The difference to the browser developer tools is that Augury is aware of the Angular architecture, and therefore it gives you a good overview over the different components in your app, something you don't see easily in the browser because the rendered DOM doesn't contain these. It gives you access at the properties of your components, the state of them. It gives you access to injections happening in your app. So a detailed look at what's happening in your app at runtime, being aware of the Angular concepts like services, like dependency injection, and so on. So definitely have a look at this too. You access it from the developer tools thereafter, and you can simply analyze your page with it, as you do with the normal developer tools, the ones implemented in the browser. So you do with that, but Augury offers some extra features that are tailored for Angular. And if you're using NGRX, you should also have a look at the Redux DevTools, which you can connect to NGRX. You can find instructions on that on the NGRX documentation. And this allows you to have a look into your NGRX store. So these are the things I want to bring to your attention to dive deeper into. These are a lot of great tools that help you debug your Angular apps. Okay, let's leave the world of errors and let's have a look at something else I get asked a lot. How can I pass data from component A to component B? So here's a concrete setup with an app component, a products component, and a product component. Now, one easy way to pass data around is by property binding. With that input and so on, you pass data from app component to products component, and maybe then data from products to product component. Property binding is only possible from parent to child component, so only one level at a time. Therefore, reaching out from app component to product component is not possible. If you wanted to do that, you would use a service instead, a service in between, possibly, or typically, to be honest, with the RxJS subject, which is like an observable, but one where you can emit events on your own, with next, so where you can emit an event, let's say from the app component, and where you then subscribe in some other place of your app, and that place could also be a service, by the way, or something like that. Now here it would be the product component, and all of a sudden we have a connection from app component to product component through the service and the subject. And this also works the other way around. We can emit our custom events to pass data up from a child to a parent component, but emitting an event from product component to app component directly is not possible. But again, we can use a service with a subject to emit an event and listen to it in another component. So this is how we can communicate between components and pass data around. Now important, if you're using RxJS subjects, don't forget to unsubscribe in the components where you do subscribe in ng on destroy to make sure you're not running into memory leaks. So you need to store that subscription you're creating with the subscribe method in some property and unsubscribe from that in the ng on destroy lifecycle hook. And let me also add, there is one other way of communicating and passing data around, and that is using NGRX, which is basically a Redux implementation for Angular apps. You want to use Angular with a server-side language because Angular runs in the browser, so a lot of the logic you want to execute can't be executed there because it needs to run on a server for security reasons, for performance reasons, or because you can't perform that action in the browser, like accessing files, or because you want to store data in a server-side database. Now, I often get asked, can I use Angular with PHP, with Laravel, which is a PHP framework, with Node, with Ruby, with anything? And the answer is yes, you can. Angular, in the end, creates the client-side app, a single-page application running in the browser. It doesn't care about your server because it doesn't run there. So you can build your server-side backend with any language and framework you want. Angular is only good at creating SPAs, so it only creates that, it only runs that, and your server-side backend now needs to be a RESTful API. So not a backend where you render views, like with Laravel's Blade templating engine, you're not doing that. Angular is responsible for the front end. Your backend is a RESTful service sitting there providing API endpoints to which Angular can send requests through its HTTP client, and where it also, of course, receives responses. And on the server, you can then implement any logic, including a database if you want, that you want. You communicate to Angular through the RESTful API. Another question I get a lot is, can I use Redux? And I already kind of answered this earlier in this video. Yes, you can with NGRX. Now, Redux solves one problem, that we have a lot of components communicating with each other and with services, and we get a lot of complex interactions that become hard to maintain, especially in bigger apps, of course. Redux solves this by offering us a Redux store, so one central place in the app where our data is stored and where we can connect our different parts of the app to. So components can then receive data from the store and dispatch actions to the store, and we have a clear flow of data and a central place where everything gets stored. And that is Redux, and we can use it in Angular. Since Redux isn't tied to React, you could implement Redux just like that in Angular, or you use a specific implementation of it called NGRX. Now, this is not a must. As I said, you can implement the normal Redux on your own, but you can also use NGRX to get an approach that nicely fits into the Angular world and follows many of the concepts Angular already follows. So NGRX is something you want to Google and you want to learn if you want to implement Redux in your Angular apps. Speaking of state, I also see the question, my state is lost after I refresh the page. And with that, people mean that unlike on traditional web apps, where you often have sessions to manage the user state on the server, and therefore if the user refreshes the page, he's still logged in and so on. In client-side apps, this is not the case. If you refresh your Angular app, it really resets. It doesn't keep the old state because no server is involved. You might have that RESTful API you are sending data to, but that is a stateless server. It doesn't store anything, any session information from your client. So you have two ways of storing state across page reloads then. You can work with local storage, which is a client-side storage, a storage in the browser, or with a server-side database. You're still not going to be using sessions then, but you can persist some general user data there, of course, like the orders of a user, stuff like that. For session-like approaches, you would have a look at local storage though. So local storage runs on the client, so it's not fully under your control. With that, I mean that if the user clears the cache manually, uninstalls the browser, or something like that, this is of course gone. But the same is true for cookies, I guess, since they're also living on the client. It's accessible by JavaScript only, so there's a good and a bad thing. Bad thing is if your page is vulnerable to cross-site scripting attacks. By default, Angular should give you a good protection against that though. If it is vulnerable, then people can access your local storage and possibly extract JSON web tokens from there. On the other hand, it's not vulnerable to CSRF attacks, for example. So that is the upside of that. It's a simple key value store. That's also important to keep in mind. That means that, well, you can't store complex data in there. You can't store images in there, really just simple data. But for keeping track of a user session, for example, of a JSON web token and so on, this is perfect. Now, the server-side database is better for data that needs to be under your control, like the user itself, the user data you store, stuff like that. It is accessible from the server only, so the client can't access it, which of course is an extra security layer. And of course you can use any database you want, and you can store whichever data and data types you want therefore. And this is how you persist state or how you store data. There is no session. You do use these two things. You can also use cookies, I should add, but you don't use sessions. That's the key takeaway. There is no session stored on the server and no session key stored in a cookie on the client. Can I host my Angular app on Heroku and so on? That's another question I see a lot. Let's understand how hosting an Angular application works. If we use the CLI or any other build process, in the end, once we're done, we're going to build our project, which means we generate a bunch of build artifacts, which is the index.html file and a lot of JavaScript files typically, the bundled and optimized JavaScript files that make up our app. So these are the build artifacts. We might of course also have some style files. These need to be shipped to a server, and these are just static files if you have a look at that. There's no server-side code, there's no PHP file. The JavaScript files are not going to contain any Node.js code. So there's no need to execute code on a server. And therefore, a static host like AWS S3 or Firebase hosting is all you need. A static host is basically a file storage that also can accept HTTP requests and return your files, but where you don't run any server-side code. So can you host your app on Heroku? Yes, you can. But since Heroku essentially requires you to create an app with some server-side language, you create a Node.js app just to serve the index.html file in the end. And the same might be true for other languages. So that might be overkill. Google for static web hosts instead to find fitting hosts for Angular apps. Speaking of deployment, another question I see a lot is, my routes don't work after deployment. So here's the setup. We got the user, you, and the server. You enter a URL in the browser and your Angular app loads, a page with your Angular app loads, I should say. You then navigate to the products page there by clicking on a link, and that page loads. This is done through the Angular router, because there you register the different pages, and since you only have one real page, the index.html file, it's not really loading a new file from the server. Angular just re-renders your page to give you the illusion of loading a new page. And it can do that because it essentially listens to the clicks on your links when you use the router link directive and, well, triggers the Angular router. Your server doesn't have any routes. If you refresh the page now, you get a 404 error, because if you refresh the page, the Angular router has no chance of taking over, because refreshing means you send a new request to the server, and since you have no routes there, except for the default route, which returns the index.html file, well, you get an error. The solution is you need to always load the index.html file. So on your server, you need to define the index.html file as your 404 error document. This then allows the router of Angular to take over and handle that request and possibly find the route and then render the correct page. And if you want to have a 404 error page for routes you don't handle in the Angular app either, you would need to set it up in Angular still. Here's another question I get a lot. Everyone can see my code. It's true. Everyone can see your code. If you go into the browser and open an Angular app and you go to that sources tab as I showed you earlier in this video, well, you can inspect the code. And everyone can do that. You can do that for other apps and other people can do it for your app. You can't protect against that. JavaScript runs in the browser. It's not compiled, not pre-compiled. So it's visible to everyone and you can't do anything about that. The only thing you can do is be aware of that and don't put sensible information in there. Make sure you only have code and information in that JavaScript file that doesn't really matter if other people can read it. You can make it harder for people to read it, but you can't prevent it. I also often see the question how you can use third-party CSS libraries like Bootstrap in Angular apps. And there are two major approaches. The first one is simple. You throw a link ref in your index.html file, either pointing to a local file you downloaded or to a file hosted on some CDN. The second possible approach is to either download the CSS file, the CSS library file you want to use, or use npm install library to install it, and then add an entry to the styles array in the Angular CLI.json file. And that entry simply needs to be the path seen from the source folder on, so not from the root folder, but from the source folder of your app on, to that file you downloaded or you installed. This is how simple you can add a CSS library. And the same for third-party JavaScript libraries. You have three possibilities here. You can put a script source import in index.html, and you can also point to some CDN here. You can use npm install or download the file and add an entry to the scripts array. Or you do the same, but directly import it into your TypeScript files by adding an import statement at the top. You can, of course, import other TypeScript files, and you do that all the time in Angular apps. Well, turns out you can also just import other JavaScript files. So that is a perfectly fine alternative. Then you don't have to add an entry to scripts to the scripts array in the Angular CLI JSON file, because if you just add an import statement in one of your TypeScript files, in the end, this imported JavaScript file will be included in the final bundle, so then you got it in your application too. One important note though, since you're using TypeScript in Angular, there are JavaScript packages that might be unknown to TypeScript, because they don't ship with a so-called types declaration file, a file that basically translates the JavaScript functionalities to TypeScript. If your downloaded library doesn't have such a file, you have to add something to the source typings.dts file you should find in your Angular projects, or which you can create if you don't have it. And there you add that declare module and then your library name line here. And thereafter, when importing it in other JavaScript files, TypeScript should understand the features of that library. You need to add an import statement then though, With the scripts array approach, this will not work. There you would instead need to add declare var and then any object you use from a library of type any at the top of the TypeScript file where you want to use it. Let me show you an example. Here's a very simple project I created. And now in there, I will install a new library with the npm install, and I will install Lodash, which is a library providing a couple of utility functions to JavaScript. I'll add -- save to download and install it, and also add an entry in the package.json file. Now, once this is finished, let's go to Node Modules and let's have a look at what we got. So here's Lodash, and if we open it, we see a bunch of JavaScript files in there because it's shipped in a way that we can import just what we need and we don't have to import all the files. One thing that's missing though, or should be missing at least, is such a DTS file. So what can we now do? How can we use Lodash? For Lodash, and for a lot of JavaScript libraries to be honest, a good approach would be the following one. Let's say we want to use it here in the constructor of our app component. There I will create a new array, 1, 2, 3, and I want to shuffle that. And Lodash has a function for that. So normally I can use the Lodash symbol, the underscore, and call shuffle and pass my array. And I could output the result of that operation. Now if I do that and I run ngserve, we already can see it here in the file that this underscore isn't recognized. TypeScript doesn't know, and therefore during building it gives me an error. It shows me that it can't find that name. Now we can import Lodash. So we can import Lodash like this, and this would be the correct import statement, but still it would fail. Now what I said is that you can now declare a var underscore, so the symbol you're going to use, and of type any, so that you're allowed to call anything in that TypeScript file. And now the error is gone, because now we're telling TypeScript, it's okay, I know that this symbol is available and you don't need to care about what I can do with it. And now if we go back to our running application and I reload the page, we see the shuffled array. So we're using Lodash here, we're importing it like this, and we added declare var. And the alternative I mentioned would be to go to the typings DTS file and add declare module Lodash. Like this. With that, it should also work if I save this. And here in the app component file, I removed the declare var Lodash thing. And now I can import underscore from Lodash. So this is now an alternative. And with that, it still works. Well, here it now gives us a shuffled result. And this is another way of doing this. Here basically using that import statement where I say I'm importing a specific symbol from that file. So these are the common approaches you use for using JavaScript packages or files, libraries. A lot of libraries already ship with these DTS files though, and have ES6 imports and exports. So there you just import something from that library and you don't need to declare the module. You can basically find it out by checking out the GitHub repositories of whichever libraries you're going to use. And that was basically it. I hope you enjoyed it. I hope this was helpful. Share any other common questions you see, in the video comments, and I will see what I can do. And I hope to see you again in future videos on my Academine channel. So see you then. Bye.